next one, we'll move on to fingerprint examinations. I hope the slide changed. So fingerprint examination, we could just put it like that. Okay, so fingerprint examination is, fingerprints are also physical evidences. Fingerprint impressions are also physical evidences. So like I was saying, everyone has fingerprints. Every individual is born with different fingerprint patterns to them. And there is only a condition called a dermatoglyphia, where a person is born without fingerprints, and it's very rare, not even 1 in a trillion. It's a very rare condition. So fingerprint examination techniques actually study different patterns of fingerprint, and the fundamental principle behind fingerprint examination, there are three fundamental principles behind fingerprint examinations, and they are: individual characteristics remains unchanged, and unique patterns. So the first one, individual characteristics, like I said, for DNA, it is an individual characteristics. Like every person, unless you're an identical twin, you will have different DNA profiles. Similarly, you have your own fingerprints, and it is your individual characteristic. No two person, including identical twins, will have same fingerprint patterns. And another advantage of fingerprint patterns, or using fingerprint patterns, a pattern as an evidence, would be it remains unchanged. It remains unchanged throughout your lifetime, unless you have a scar, or unless your skin peels off, then more than like your epidermal dermal layer, the fingerprint on your hand and your fingers will remain unchanged. And then the third one is unique patterns. So human being, specific to human being, we have 4 unique patterns of fingerprints, and then that fingerprint patterns will only be specific to human beings. So it is easy to say that it's not from any other animal, it's just from humans. So these are the 3 main principles, and that makes fingerprint impression highly significant for forensic analysis. So in one word, you can say fingerprints are very significant just because it can identify a person, individualize a person. So again, in the crime scene, if you happen to get a fingerprint, and if you can match that fingerprint to one person, you could say that person was present in the crime scene. So fingerprint impressions are mainly found on 3 different ways, and the first one will be latent fingerprints. Latent fingerprints are, if you guys have watched movies, you can see that people, they dust something on the floor and the fingerprints will appear. So it's the same way. Latent fingerprints are not visible to our naked eye. It's hidden fingerprints, and it's like it the ridge patterns on our fingers, on our thumb, or on our any other finger, getting transferred to the surface when we touch the surface, as latent fingerprints. And patent fingerprints, unlikely to latent fingerprints. Patent fingerprints are visible fingerprints. So if you touch paint, if you touch blood, and then you put your hand somewhere, so you could actually see fingerprints on a surface. So patent fingerprints, we can, in a broader way, say it is visible to our naked eye. And then there are plastic impressions. Plastic impressions are 3D impressions that will, it's basically removing an object, where you deposit your fingerprints by giving a what to say, a dimension to the surface. So individualization is the key concept, and it is this significant part of using fingerprint examination in forensic science. So we have fingerprint bureaus, we have fingerprint like analysis team, and like fingerprints are used not just in court, for other biometric like visa, passport, Aadhaar cards, and everywhere, to individualize a person. So fingerprint directly links to you. And then the next discipline is document examination. So nowadays we see every day in newspapers that, okay, there was a forgery, there was someone who did this. Can someone confirm that the slide changed? Sorry. It's,
Ma'am, slide is not changing. And
is it okay now?
yeah.
Yeah, okay. So for document examination, so you might have seen in a lot of movies and you might have seen in newspapers and everywhere that uh, when you like people signed, it is my fake signature, that's not my signature, someone signed on behalf of me, there was some alterations on the paper, there was some obliteration that happened, somebody erased this number, I signed for 10,000 rupees but they added another zero to it. So there are a lot of document frauds that is happening these days, and there are a lot of people, they might just tear a page of the document that they wrote. So there are a lot of obliterations and alterations happening to a document. So not just printed documents, handwritten documents. So this discipline of forensic science will study all these um, like factors or aspects related to document. And there is another interesting part to this document examination part, which is if the document is handwritten and then you have toned the page based on the indentation of the writing, that if you put enough pressure and you could see that if in normal day, like if you're writing a note like lecture note or something, if you put so much pressure in your notebook, if you turn the page, you can see the impression on the next page. You can actually, if you put it in an oblique angle, you can actually read what you wrote just based on the indentation. So there are technologies that use like electrostatic SDA, like the lifting apparatus, where you actually read and cast what that person wrote based on the indentation on the next page. So even though if you tear the actual page, if there is the next, if there is the subsequent page having all this indentation, you could actually know what that person wrote. So document examination, especially in this present scenario, it is very important. So this is another important part of document examination, forensic science. And then the next one is digital forensic science. So digital forensic science is, I'm not that expert to talk about digital forensic science because it's entirely different from applying basic science knowledge, but still digital forensics is another area where you use the knowledge of technology in solving crime. So digital forensic science not just involves cybercrime. It can also be financial frauds, hacking, identity theft. You making a fake passport. You making digital forensic science can be anything. Like you're forging your fingerprint document on a passport. So there are multiple things. So digital forensic science is something you use knowledge of IT, that is internet and information technology, in solving digital crimes, financial frauds, identity theft, and things like that. So I hope you guys could follow what I was saying about all the disciplines of forensic science. So now I'm going to talk a little bit about how forensic science developed to this stage, or a few feathers in the development of forensic science over the years. So so the first one is Matthew Orfila, the scientist called Matthew Orfila, and the first feather happened in 1814. And you could say Matthew Orfila is described as father of forensic toxicology. So, as I was saying, toxicology is analysis of biological samples for the presence of any toxin. So, he published the first scientific document on the detection of poison and their effects on animals. And after that, another feather on the crown of forensic science, we could say, is by Alphonse Bertillon. So Alphonse Bertillon, he had first scientific system for personal identification. So he used body measurements to identify. So as I was saying, the forensic science is all about individualizing and proving a crime in court, like with the help of evidences and evidence analysis. So personal identification using body measurements is also crucial at that stage back in 1879, because there was no DNA, there was no serology, there was nothing like that. So he used body measurements to individualize or personalize people. And then Next person is Francis Galton. So I was talking, while I was talking about fingerprint examination, I did mention that how significant fingerprints are because it is a unique and individual characteristic, and no two people in the world share have same fingerprints. So Sir Francis Galton, he had the first definitive study of fingerprints and developed a methodology of classifying them and used it for criminal investigation. So the next important person will be Leonie Lattis. And you all might have heard about ABO grouping, right? We have A blood group, B blood group, a, B, and O, and there will be positive or negative based on the presence or absence of Rh factor. So it was Leonie Lattis who devised a relatively simple procedure for determining the blood group from dried blood stain. So a technique they used frequently, and it was immediately implemented on crime scene investigation. And then the next development was from Calvin Goddard, who actually came up with an idea for comparison of fired bullets. So now you can say you need to have, just imagine a crime scene and you get a fire, like a fired cartridge case or a bullet. So if you have to compare that bullet with something else, you need to have a comparison standard. So he's the one who came up with a test fired bullet and used a comparison microscope where you could put two samples, one as his test fire, like he fired it for as a standard, as a comparison, and another one that was collected from the crime scene. So even now in this most advanced stage of forensic science, the comparison microscope is an indispensable tool. And next important person is Albert S. Osborne. He uh, came up with fundamental principles for document analysis, like question document examinations. And then there is Hans Gross. So Hans Gross, actually, if you could say, like a handbook for forensic science. He came up with his publication was the first publication which had which described the application of scientific principles or scientific disciplines to the field of criminal investigation. So we could say, like, Hans Gross published the first handbook for forensic science. And the last one, and the most important one, all of the above were important, but Edmund Locard's Edmund Locard's contribution to forensic science was very important. And even now we believe in that principle. And Locard's principle of exchange, the principle is, or the theory is called Locard's principle of exchange. So the theory says whenever two objects come into contact with one another, there is exchange of material between them. Or you could say, if there is, every contact leaves a trace, or if there is a contact, there will be an evidence left behind. So if a person, so let's assume a person is entering a crime scene and he knows nothing about controlling evidences or anything. He happened to be doing some crime, and there is a person in the crime scene and he touches a table. So he leaves his, just by entering the room itself, he might have left his footprint, he must have left his shoe print, he must have left some of his hair, he must have left his fingerprints, he must have left some fiber from the cloth, or he has opened a window and there might be some glass fragments on his body. So anything, so any physical contact leaves a trace behind, or if, and whenever two objects comes in contact with each other, that leaves a trace, and that trace can be extracted as a form of evidence. And that's what Edmund Locard came up with, and that's still the basic principle that we use in forensic analysis. So this is the, and then I haven't added anything after this, like I've only added things till 1920s here. So there is 1986 DNA analysis and everything, but these are major development back in times when there were not much advancement in technology. So the next one is firearms analysis. Sorry. Yeah. So, sorry. Next one is forensic analysis. So, in any, we could say, like, like I said, forensic science. In forensic science, we establish link between crime, crime scene. evidence, like perpetrator and victim using evidences. So there is a method and there is a procedure, series of procedure that we follow in any forensic analysis. So the first ever step in a crime scene investigation or in a forensic analysis is called recognition. What is recognition? Recognition is like the term suggests, it's recognizing an item as a potential evidence. Again, let's assume you are a crime scene investigator. You're going to a crime scene and you happen to see a cigarette butt and you just ignore it, saying, okay, someone might have just left it accidentally. No, right? That cigarette butt could have saliva of the person who used it. It could have fingerprint of the person who touched it. It could have many evidences associated with that. So going into a crime scene and seeing a cigarette butt and thinking that, okay, that was a potential evidence that I could use for further analysis and could use in criminal investigation. So recognition is basically recognizing an evidence in the crime scene as a potential evidence that you could use in further analysis. So once you recognize the sample is when you identify the sample, and there are multiple sub steps under each processes, but these are the four main steps you use in a forensic analysis. So once you recognize the sample, you identify the sample, you identify the like various forms of evidences. So if you see a tool mark, you associate that with physical evidence, or if you see some blood stain, you identify it as a what to say, biological evidence, or if you see some drugs or a white powder, you associate and identify it as a chemical evidence, and you in, do its initial identification process where you do presumptive and confirmatory tests to identify the presence of blood in a brown stain. Like I said, you can't say any white powder is salt in the kitchen, right? Like that, you can't say any brown stain is blood. It can be anything, it can be just watercolor. So in court, you can't assume anything. So there was a brown stain, so I assume that's blood. No, you can't assume anything. So you identify the form of evidences and then you compare their class characteristics. And that's how you come into individualization, the third step. In individualization, you actually link that particular evidence to a person. In that individualization step, you identify, after identification, you individualize the person, you link that particular sample to a person. So first three steps are very crucial, and it is very important to do the first three steps correctly to come to the fourth step. So the fourth step is reconstruction, and reconstruction is completely dependent on first three steps. So reconstruction utilizes investigative information and crime scene information and laboratory analysis, the results we got, physical and physical evidences, pattern evidences, all these things to reconstruct the crime scene. Reconstruct the crime scene is by is maybe the determination or elimination of events or actions to say what actually happened and how that evidence came there. So it's basically reconstructing the crime recordically, reconstructing the crime or reconstruction of evidences to prove what has happened. So there is no loophole for the criminal or anyone to escape from the case. So this is the very basic and initial, like, four steps that we use in forensic analysis. So I have tried and used maximum simple terms so that you guys can understand. And so these are different disciplines of forensic science, how forensic science developed, and how we do forensic analysis in the lab, and what are the steps we follow in forensic analysis. So every evidence will have its own analysis, its own standard operating procedure. How do you extract DNA evidence? It is not similar to how you do a drug analysis. It can be different. So all these steps uses multiple technology, multiple instrumentations, multiple machines, multiple methods, multiple people, and it takes multiple, like, different durations dependent on the sample. But these are the basic evidences, like steps that we use in forensic analysis. So next thing is career options that I said I will talk a little bit about career options in forensic science. So before I talk about career options in forensic science, I would like to talk about a little bit academic like a little bit academic perspective of forensic science. So, like I did my bachelor's and master's in forensic science, but I highly vouch for doing a bachelor's in any normal science like BSc Physics, BSc Chemistry, Biotechnology, whatever, normal science, and doing a master's in forensic science to keep your career path broad and to give you more expertise in one of the disciplines. So having BSc Forensic Science and MSc Forensic Science will lack a stronger foundation in science, which you will have to do multiple papers, or you will have to do one or two additional papers in your master's year to strengthen your undergrad degree. And another thing I would like to talk about before talking about career options is, so there is something called CSI effect, which is called crime scene investigation effect. If you Google that, you can see that a lot of people, they get influenced and inspired by crime scene investigation series like Crime Scene Investigation, Forensic Files, or other web series, documentaries, and everything, and they or movies, and they take forensic degree and they get a job. But once they go into the profession is when they realize the actual forensic laboratory is nothing similar to what you see on movies or what you see on your web series. Or so in TVs, you can see people just seeing a touch DNA, and then in a 5 minutes they put it somewhere in a machine and you're getting a DNA profile. But actual forensic processes can take 3 to 4 days, maybe longer. And obviously, I understand you can't show a movie for 5 days, but there are a lot of things where, excuse me, where people actually show false information on TV, and students and especially kids, they're getting inspired by all those series and all those videos and all those modern, sophisticated laboratories, and getting into forensic science, and they have to work in completely isolated labs, completely gowned up. So whatever you see in TV is not real. Which is entirely different. They have taken elements from science, but that's not actually always true. So it's always better to talk to people who actually work in the field before deciding to go into forensic science. So forensic science, a major career option with forensic science would be research. I would say being a forensic scientist doing research, because forensic science is evolving day by day. You have new papers getting published every day, new technologies coming up every day. Even though when I started my bachelor masters, I did my master's with a specialization in touch DNA from firearms and ammunition. And but just after I submitted itself, there are a lot of new techniques and a lot of new methodologies that came up during my study, after my study in last 2 3 years itself. So forensic science, the research behind forensic science is spontaneous, is growing so fast. So research is a good career option where you can be a scholar, you can get your PhD, or you can still do research being a forensic scientist. And you can and being a forensic scientist itself gives you multiple options. Like you may be called into court as an expert witness, that's law students, most of you might be familiar with. So you can give expert testimony in court about the evidences you analyzed, or based on your expertise. And based on all the disciplines that we discussed before, you can be a document examiner, question document expert, fingerprint officer. You can be a scene of crime officer, where you go to crime scene and you collect evidences and you bring them back to, and bring them back and hand it over to exact, like divisions of forensic science for analysis. And you can be a DNA scientist. You can be a in physical evidence, where you can be a firearms expert. So there are multiple options, multiple career options, but you have to be very careful while choosing your discipline, because all these jobs are highly skilled jobs where you need to have your expertise, you need to follow, and you need to mandatorily follow some guidelines by international organizations like a NAB, American accreditation body. So then only your work, the testimony you give, and everything will be completely admissible in court throughout the globe, I would say. So these are the career options that you could follow after a forensic degree or studies. So these are the references, and I would be